this lesson, we're going to learn how to solve quadratics using the quadratic formula. When we use the quadratic formula, it must be in the form of ax squared plus bx plus c equals 0. Now, the quadratic formula can be used to solve for any quadratic function. But remember, our equation must be set equal to 0. So here is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now the plus or minus is what gives us our possible two solutions. The expression under the radical b squared minus 4 times a times c is called the discriminant. This expression can tell us how many roots the quadratic has, and if they are real or complex. This gives us an idea of how many places our parabola crosses the x-axis. So if our discriminant, the expression under the radical of the quadratic formula, is greater than 0, if we have a positive radicand, then we know that it crosses the x-axis at 2 places on the x-axis. If the discriminant is 0, then we just have one root, one solution. And if the expression is a negative, meaning we have a negative under the radical, then we have no real roots. So let's practice finding the discriminant. So remember, our equation must be set equal to 0. And we can see in number 1 that it's set equal to negative 8. So we're going to add 8 so that our expression, negative 10x squared plus 2x plus 2 is equal to 0. Now we can identify the a, the b, and the c, the coefficients of our terms of our quadratic. A is negative 10, b is positive 2, and c is positive 2. Now let's use the discriminant, the expression under the radical, and let's find how many roots we're going to have. So d is equal to b squared. I always like to use parentheses when I'm using my exponents, minus 4 times a times c. 4. Now here's where I always pause. I decide what kind of operator I'm going to have. We have a negative times a positive, so that's going to be plus. This is the place where if a mistake is made, this is where it could be. So always find what kind of sign you're going to have before you calculate. Then we simply have 4 times 10 times 2. So that's going to be 80. And our discriminant is 84. So 84 is greater than 0. So this quadratic has 2 real roots. Number 2, again, we need to have our equation set equal to 0. We can identify the a, the b, and the c. We're going to plug in b, negative 4, squared minus 4 times our a value times our c value. We square b, it's always going to be positive. Then we find what kind of operator we're going to have. A negative times a negative times a negative is minus. So this is 4 times 2 is 8 times 2 is 16. And d equals 0. So 0 equals 0. This tells us we have one real root. Number 3, subtract 2. Identify your A, your B, and your C. Find the discriminant. B squared minus 4 times A times C. We square our B value. Our operator is subtract. We're going to have 4 times 5 is 20, and 20 times 10 is 200. Our D value is equal to negative 184. D is less than 0. And let's fill that in. So I'm going to go ahead and put in the value there. So we have negative 184 is less than 0. So we have no real roots. It does not cross our x-axis. And number 4. A is 1, B is 5, and C is 4. D equals B squared minus 4 times A times C. Square your B, identify the operator, and D is going to equal a positive 9. So 9 is more than 0, so we have 2 real roots. Okay, let's just continue, and now let's actually find the roots. So again, our equation must be set equal to 0. It is. Our A is 1, our B is 2, and our C is negative 15. To find the roots, the x-intercepts, we're going to say negative B, so we have negative B plus or minus. This is where our possible 2 solutions comes from. We're going to plug in 2 for B squared minus 4 times A times C all over 2 times A. Now let's simplify. We have negative 2 plus or minus. Square your B, identify your operator. Negative times negative is positive. So we simply have 60 all over 2. Negative 2 plus or minus the square root of 64 over 2. Now I'm going to take the root of 64 and I'm going to have negative 2 minus 8 over 2 and negative 2 plus 8 over 2. So here's where the 2 roots are coming from. So negative 2 minus 8, that's negative 10 over 2, which gives us negative 5. And then we have 6 over 2, which gives us 3. So our 2 roots are negative 5 and 3. Our equation is set equal to 0. Our A is 2, our B is 2, and our C is negative 60. We have negative from the formula. B is 2 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Let's simplify this. We have negative 2 plus or minus, square your B, identify your operator, negative times negative, so that's going to be plus, so that's going to be 4 times 2 is 8, 8 times 60, so 8 times 6 is 48, plus your 0, all over 4. we're going to have our two roots, negative 2 minus over 4 and negative 2 plus 22 over 4. So this root is going to be negative 24 over 4, which is negative 6, and we have 20 over 4, which is 5. So our two roots are negative 6 and 5. Now sometimes our equations are not going to give us integers. They may give us radical expressions or even rational expressions. Our A is 1, our B is negative 10, and C is 25. Our x-intercepts, we have negative B plus or minus the square root. We have B squared minus 4 times A times C all over 2 times A. So it is a very good idea to make sure you plug in everything exactly how it is using the formula, and then just simplify one step at a time. So this gives me positive 10 plus or minus. We square our B. It's always going to be positive. We identify the sign. Get 100 over 2. Now, here we have 10 plus or minus, and that's going to give me 0. So because I'm not going to be adding or subtracting anything, this is where we're only going to have one root. We're just going to simply have 10 over 2, which equals 5. So our solution is 5. That means our root, our x-intercept, is actually the vertex. And we'll learn about that in another lesson. But this has one root. So this is our discriminant. Remember, when your discriminant is 0, this is why you only have one root, because this plus or minus is not going to be used because we just have 10 over 2 because it's plus or minus 0. Our next one, our equation is set equal to 0. A is 5, B is negative 4, and C is negative 64. Plug in, we have negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Again, it's very important. Just plug in everything. On your first step, use some parentheses and being really careful when you're plugging in. Now we have 4 plus or minus. We're going to square our B. We're going to identify the operator. Negative times negative, that's plus. And then we have 20 times 64. 1,280 over 10. This gives us 4 plus or minus 1,296 over 10. And let's see if 1296 is a perfect square. It is. So we're going to have 4 plus or minus, that gives us 36 over 10. So this is going to give us 4 minus 36 over 10 and 4 plus 36 over 10. So here we're going to have negative 32 over 10, which gives us negative. I'm just going to divide each one by 2. So that's one root. This gives us 40 over 10, which gives me a root of 4. So we have negative 16 over 5, and we have 4. Now, if I were being asked to plot these solutions, these roots on the x-axis, I would convert negative 16 over 5 into a mixed number. On this problem, we need to first subtract 2, and we have 6x squared plus 7x plus 10 is equal to 0. Now our a value is 6, our b value is 7, and our c value is 10. So we're going to plug in. We have negative 7 plus or minus our b value, 7 squared minus 4 times a times c over 2 times a. Let's clean this up. Square the b, identify the operator, and 4 times 6 is 24, times 10 is 240, all over 12. Negative 7 plus or minus, and when I subtract this out, I'm going to get a negative radicand, and so that's going to be negative 1, looks like 191 over 12. Now, because I have a negative radicand, I'm going to have no real solutions. We cannot have a negative radicand. This quadratic is not going to cross the x-axis. Let's do one more. We're going to subtract 8. Our a is 2, our b is negative 6, our c is negative 16. We have negative b plus or minus our b value squared minus 4 times a times c all over 2 times a. This gives us a positive 6 plus or minus. Square your b, identify your operator, and we're going to have 4 times 2 is 8, and 8 times 16 is going to give us 128 all over 4. 6 plus or minus, we're going to have 164 over 4. Now 164 is not a perfect square. It's going to break down into 4 times 41. So that's going to be 2 root 41 over 4. Now we can leave it written like this because we're just going to have a radical solution, 2 of them, the plus and the minus. But always check to see if you can simplify these values. And if all 3 of these can be simplified by the same factor, we need to reduce that. So 2 can divide into each of these. So we're going to have 3 plus or minus the understood 1, radical 41 over 2. Or you may see it written plus or minus radical 41 plus 3 over 2. So these are our 2 solutions. And if you needed to plot these, you would use your calculator to find the estimate of radical 41. Okay, I do want to do one more, and the reason is because in this problem, we have no b value. Our b value is actually 0. So I should say we have no linear term. So our a is 8, our b is 0, and our c is negative 7. So x equals, we're going to have 0 out here. So we're going to have, and I'm not going to put the negative because 0 is neither negative nor positive. And then we square the 0, minus 4 times A times C over 2 times A. So we have plus or minus. We're not going to have the 0, but the operator is what's super important. We have a negative times a negative. So we are going to have a positive radicand. So that's where you want to be very careful. So we have 32 times 7, and that gives us 224 over 16. So 224 can be broken down into 16 and 14. So our solutions are going to be plus or minus. We're going to take the square root of 16, which is 4, radical 14 over 16. Now, let's simplify the 4 over 16, and that's plus or minus 1/4. And remember, this radicand can't be simplified by that factor of, well, 4 couldn't go into it anyway, but even if, just remember, radical 14 is a different type of number than our 4 and 16 here. So here are the two solutions.